He is a senior research data scientist at RTI International, specializing in AI, machine learning, and natural language processing to address challenges in public health, education, criminal justice, and addiction. He previously served as consulting services lead and machine learning engineer for Explosion AI. He partners with subject matter experts to explore how the intersection of data science and software development can create innovative solutions for complex problems. Let's welcome Peter Baumgartner.
All right. Hope you're ready to nerd out with me a little bit. I've got 200 slides of equations, and I got to get through them in like 7 minutes. So we're going to talk about evaluation. Click. Oh, lots of, okay, there we go. All right, so I'm just kidding. We're going to talk about 2 different questions today. The first question we're going to look at is, how do we know if an AI system works? I'm going to walk through 4 different methods we can use to answer this question. We're also going to talk about how we can use evaluation to help build AI systems. And I'm going to walk through 4 practices we can do to help us build AI systems. Now, when I talk about AI systems during this presentation, I'm generally going to mean anything that interacts with a large language model, but a lot of these principles and practices will apply to traditional machine learning as well. There we go. I get better at pointing. Let's talk about the first method that we can use. It's just vibes. So good news. If you've interacted with ChatGPT or a large language model and you've looked at the response you get and you can say, I like that, or that's not very good, congratulations. You're a junior machine learning engineer. You've just done a vibes-based evaluation. So vibes-based evaluations are really nice. They're a nice informal way to do an evaluation. You don't have to think about it too hard. You don't have to really outline what you're going to do. You're just going to do a basic sanity check. There are some downsides to just using vibes, right? Humans are subjective. We're not reliable. Our opinions change day to day. It's really hard to track these things over time. Most importantly, it's really hard to scale this type of evaluation to a lot of examples so you can understand robustly how your system performs. So that brings us to our first practice, which I would call document your decisions. So even if you're doing just a vibes check, if you document what you input into a system, what you get out of that system, and any thoughts or observations or reflections on that, and you do that over a set of examples, what you're going to do there is build an evaluation data set. And that's going to be really useful to you as you build and evaluate an AI system. Start collecting these examples over time. All right, the second method for doing evaluation is something I called not wrong. So the idea here is that there are many more ways for an AI system to fail than there is to succeed, especially if you're building something that has a lot of component parts, tying them together. A failure at any point is very simple, very easy to encounter. So the idea with doing this not wrong method is take a look at your output and classify it as either wrong or not wrong. The nice thing here is that you can begin to aggregate these statistics over that evaluation data set that you're collecting and have an understanding of the failure rate of your system over time. There are still some downsides to this. It can still be subjective. You sort of lose some nuance. You might have a complex situation where the output's sort of partially right and it's unclear what to do with that. It also doesn't tell you like what makes a good answer. It's just focused on avoiding problems in your system. Luckily, we have a practice for that. So as you begin to review the output of your system, one practice you're going to want to do is characterize what correct is. So this can mean looking at attributes of good responses and good outputs, coming up with a checklist of those attributes, even developing a rubric with levels so you can understand what makes a good response. Once you do that, you're going to have something very useful for our next method of evaluation, which is using a large language model as a judge. So this is a practice that is currently going on in people evaluating AI systems. It's a little bit meta, but you can use a large language model to evaluate a large language model. It's actually very nice because it can evaluate complex tasks. You can quantify the quality of the output. And this is the first method that sort of scales to a bunch of examples if you want to do that. You don't have to do as much human review. Now, there are some downsides. It can cost a lot of money if you need to use a service for this. It requires you to get those clear task definitions and an idea of what a good response is and build a rubric or a checklist. And finally, there are a lot of ways in which large language models are biased and might influence your evaluation in a way that you might not find helpful. So as you build your AI system, you're going to come to a point where you're thinking, well, what should I work on? Like, what should I do next? I have a bunch of examples. And I would put forward that you should focus on areas where your system has trouble, the places where you're having errors. This might seem obvious, but a trap that you can fall into is focusing on the examples where you're trying to improve on something that's already good or successful, or you get a little bit of a perfectionist streak around making sure you have the best possible examples. I think it's much better and much more useful to raise the floor of the quality on your system rather than increase the peak of the system while you have a bunch of ways that system can still fail. All right, our last method is using formal metrics. So if you've been in data science or machine learning, you've probably used these before. These are things like F-scores or metrics like Rogue or Blue. These are really nice because you can associate a number with an output from a system. And what that means is you can track how that number goes up or down over time as you improve your system. So this is really great. It's well defined. There are some downsides. It can oversimplify this idea of performance, so not everything can just be distilled down to a single number. You also can get into what I would call metric tunnel vision, so where you're just focusing on make number go up instead of thinking about the larger system or context that you're building for. It's very easy to kind of lose the forest for the trees with this. All right, so the last practice here is make milestones from measures. So with everything but the vibes-based evaluation, you have something that you can aggregate and calculate over time. And I think it's the best practice when starting a project that's going to use AI to get to a point where you're able to evaluate the system end to end and build a baseline. And the goal in that project should be to iteratively improve on that baseline by making milestones out of how much you want to improve in your evaluation. So to review, we've covered 4 different methods we can use to understand if an AI system works. We've covered vibes, we've covered assessing whether things are wrong or not wrong, we've covered using a large language model as a judge, and we've covered formal metrics. And we have covered 4 practices you can use, if the slide advances. There we go. To help you build AI systems, document your decisions, characterize what correct is, target your troubles, and make milestones from measures. Thank you.
Questions? Questions for Peter?
Hey, Peter, thanks for being here. I come at this from a software development standpoint where input X equals output Y, and we would write tests to verify that what goes in comes out the way we expect. Given the way AI works, and there can be so many different variations for the output, how does one go about testing what correct is, especially at scale?
Yeah, that's a great question, and I will also say as a data scientist, I've learned a lot from software developers about using testing to do this sort of thing. So it's definitely a challenge because you have, in some cases, non-deterministic output. You might get different things given the same input. It's hard to do that evaluation at scale. Some things I've seen are some evaluation metrics are sort of similarity based. So if you're looking at sort of like a gold standard output and the output you get from your system, the similarity between those two might change over time for any given test, but as you can set a threshold to say, like, well, as long as I run my test, I might get a different answer, but as long as this answer stays above that threshold, I'm going to count that as good. So that's something you can do. It's also an opportunity for a method called ensembling. So a lot of times, like, you would take multiple outputs from a model, aggregate them or combine them in some way, and a lot of times that can sort of like smooth out the variability you get between responses, and you can test against sort of like the ensemble output instead of any individual output.
Other questions for Peter? We'll go back here.
Thank you. So if we are using the model itself as a judge, when are we going to hit a point where we actually don't know if this is doing well or not? Because the model knows more than we do when it does the judgment.
Yeah. So that's a great question. Like, there's sort of a recursive evaluation problem, right? Where at some point you need to evaluate the evaluator, right? Yeah, there's a lot of interesting work here that's being done where people are sort of answering this question, and they're understanding, like, what are the biases of large language models as evaluators, and how do we get them to do evaluation in a more consistent way. The sort of best practice right now is to simultaneously do like a large language model evaluation combined with a human evaluation and calculate agreement metrics between those two. That's sort of best practices, but there's always the question of, like, you do that on a sample set of data, but then, like, does that scale and does that agreement sort of apply to, or does it generalize to different examples? So yeah, ongoing research for sure.
We are going to move on for time. Thank you, Peter, so much. Great information.